Okay, so here we're looking at a proof by induction question. It's a series proof by induction question. It says 1 plus 4 plus 7 plus 10 plus ... 3n minus 2 is equal to n over 2 by 3n minus 1. So what are the steps to proof by induction? Well, we have 3 key steps to focus on, and we'll come to them now in a second. But starting off with step 1. It says prove true for the smallest allowable n. Now there's no restriction on this question. We will come to a section where we have to do inequalities in proof by induction, and there will be a restriction, but there's no restriction, so we say n is equal to 1. So subbing in 1 here, what do we get? 3 by 1 minus 2 is equal to subbing in 1 on the right hand side, 1 over 2 by 3 by 1 minus 1, multiply it all out, yeah, 1 is equal to 1, which is true. Okay, so really important to do step 1. Step 2 is really simple then. Put a red bracket around any of the ends, because step 2 says to prove true for the smallest, not prove true for the smallest allowable n, it says assume true for n is equal to k. Okay, so anywhere where you see an n in the question, you should sub in a k. So assume true for n is equal to k. Make sure you write down step 2 and actually write it out. And write out the series. So this is our assumption that we're assuming to be true. Really important to write that out. Step 3 is the actual proof part. So as I was saying, this is our assumption. As far as we're concerned, it is true. So step 3, prove true for n is equal to k plus 1. So it's important you go back to the start, and anywhere here that you see a red bracket, you are now putting in a k plus 1. So step 3. Now you might be wondering, why have I included this here? I thought we were just putting in a k plus 1. Why is there just a k here? Well, if we think of the terms, this is the first term, second term, third term, fourth term. This would be the kth term, and this would be the k plus 1th term. Or on the right hand side, I've just subbed in a k plus 1, that's fine. So the trick to the question is to include this kth term, because it is identical to what is on the left hand side of step 2. We're going to use our assumption. We're going to use this. So instead of writing in the ... I can replace it with all of this. So replace it with that, and now all I have to do is show that the left hand side is equal to the right hand side. Okay, a little bit of simplification there in the middle, I suppose. So I think multiply everything by 2 to get rid of the fractions, and then start to multiply it out, and you will find that the left hand side equals to the right hand side very, very quickly. The left hand side equals to the right hand side when you do multiply it out. So hopefully you won't forget then that after the first 3 steps, so step 1, prove true for smallest allowable n. Step 2, prove true or assume true for n is equal to k. Step 3, prove true for n is equal to k plus 1. There's a sort of unofficial 4th step, which is to write down your finishing statement. So here, the unofficial 4th step is what I call it anyways. So it's true for n is equal to k plus 1, assuming true for n is equal to k, also true for n is equal to 1, which was step 1. So this is step 3, step 2, step 1. And then just write out the statement again that we began with. And it's true for all n's and elements of the natural numbers. As simple as that.